Hi everyone, my name is Amilda Balata from Department of Industrial Chemistry at the Faculty of Natural Science, University of Tirana. I'll be presenting the importance of microbiological assessment of bottled drinking water. Drinking water is very important for our health because tap water quality has decreased, so many people now prefer bottled water. Water quality is tested by checking its physical, chemical, and microbiological properties. Water can be contaminated by microorganisms, which is a big health concern, like as heterophic plate counts that show water quality and how well it's been treated, by pathogenic bacteria like Salmonella, Shigella, Escherichia coli, and total coliform or fecal coliform that show possible pollution, and some virus, protozoa, and sometimes molds. The main source of microorganisms in drinking water may be natural water source, inefficient treatment system, unsafe packing condition, improper transportation and storage, and also bad hygiene of workers. These microorganisms can pollute water and pose a risk to human health. So, the aim of this study is to evaluate the microbiological quality of bottled drinking water sold in local markets. So, the object of this study are to determine total aerobic mesophilic microorganisms, total coliform or antibacteria, and to compare the microbiological quality between different bottled water brands. So, the number of the samples that we have analyzed are 13 samples of natural and bottled drinking water. These samples were collected from different markets in Tirana. They include both local and foreign brands. The samples were chosen randomly from different places. All samples were tested right after collection using standard microbiological methods. To estimate the total aerobic mesophilic bacteria and total coliform, we use plate count agar and McConkey agar, and we use the standard pour plate method. So, for each sample, 1 milliliter of water was placed in sterile petri dishes, and all petri dishes were incubated in proper temperature. After, we count the colony and calculate the number of bacteria per milliliter. After, we did gram staining slides to look at the bacteria under microscope. So, the results were grouped into two tables. The first table includes results of samples from local bottled water brands, and the second table shows the results taken from foreign bottled water brand. From the first table, we can see that all samples had some aerobic bacteria except sample 2. sample 2 showed the highest quality and was microbiological safe with no bacteria or coliform detected. The total aerobic mesophilic bacteria varies from 0 to 10 to third power colony-forming units per milliliter. The highest bacterial counts were in sample 3, 9, and 8. The lowest counts were in sample 1, 7, both with 2 colony-forming units per milliliter. Sample 1, 2, 7, 4, and 5 resulted that have the total aerobic bacteria within the permitted limits. Sample 8 were in borderline, while sample 3, 9 exceed the safe limits. So high bacteria levels usually come from poor treatment, hygiene, or storage. We can see from the table that no coliform bacteria were found in any samples. This graphic shows the logarithmic values of total aerobic mesophilic bacteria load. All samples show the presence of aerobic mesophilic bacteria loads from 0 to 10 to third powers colony-forming units per milliliter. It is clear that in the first group of local water samples, the highest bacterial load is found in samples 3 and 9, while the lowest load is in samples 1 and 7. Sample 2 show no aerobic mesophilic bacterial loads at all. The second table shows the result from foreign bottled water brands. The total aerobic bacterial loads range from 11 to 158 colony-forming units per milliliter. The highest bacterial load was in sample 11, followed by sample 12 and 13. Sample 10 has the lowest bacteria load. According to permitted limits, sample 10, 12, 13 were within permitted limits. Sample 11 exceed the limits, possibly due to contamination or poor storage. No coliform bacteria were found in any sample. That means no fecal contamination. In conclusion, sample 10, 12, and 13 had good microbiological quality, while sample 11 is not acceptable due high aerobic bacteria. This graphic shows the logarithmic values of total aerobic mesophilic bacterial loads. All samples show the presence of aerobic mesophilic bacterial loads from 11 to 158 colony-forming units per milliliter. It is clear that in the second group of foreign samples, the highest bacterial load is found in sample 11 and 12, while the lowest load is in sample 10. This graphic shows that all bottled water samples show some aerobic bacterial load, except sample 2, which has 0 colony-formed unit per milliliter. The bacterial load ranged from 0 to 3,000 colony forming units per milliliter. The lowest lows were in sample 1 and 7, while the highest lows were in sample 3 and 9. According to permitted limits, samples 2, 1, 7, 10, 13, 4, 5, 12, and 8 are within permitted limits, that means with good microbiological quality, while samples 3, 9, and 11 are exceeded the limits. So, in conclusion, we can say that the total aerobic bacterial loads in bottled water samples range from 0 to 3,000 colony forming units per milliliter. Some samples were within the allowed limits, sample 1 to 7, while others exceeded. Example, sample 3, 9, 6. Samples 2 had the best microbiological quality with no bacterial loads, no total coliforms. The presence of bacteria suggests possible contamination during production, storage, or transport. All samples were safe regarding to total coliform bacteria and total fecal coliform bacteria. The study showed that bottled water quality is not always stated safe. There is need for regular microbiological testing, and we recommend better production, packing, storage, and transport practices to improve water quality. As conclusion, strict control and continuous monitoring of all stages, production, packing, storage, and transport are essential to ensure safe bottled drinking water for consumers. Thank you.